A set is a collection of objects. In a set, we don't care about the order. We don't allow repetition, and either something is in a set or it isn't. So here's an example of a set right here. This we're calling this set A, and it has 4 elements. The elements are the individual things that are in the set. So in this case, we have the elements. We have 1, 2, 5, and 9. When we're talking about sets, most of the time in math, well, at least for this class, we're going to be talking about a lot of sets of numbers. Sets don't have to be of numbers, they're just a collection of general objects, so you could have sets of sets, for instance. We've seen matrices in this course, so you could have sets of matrices. But like I said, order doesn't matter, so this set right here, 1, 2, 5, 9, this would be the same as if I had 2, 1, 5, 9. All we care about is whether or not something is in the set or not. So, like I said, the order doesn't matter. And we also typically don't have repetition. So if you're listing out a set, you wouldn't see 2, 2, 1, 5, 9. We would just not write it the second time because either the 2 is in there or it's not. It can't be in there multiple times. There are, if you get into, well, there are some things called multisets, but we're not getting into that in this course. All right, so this method that I'm using here to list out the elements of the set, this is called the roster method. And just like a team has a roster, if there is a football team or something like that, the roster would be the list of everyone that's on the team. The roster method explicitly lists all of the elements in the set, so you can kind of remember the naming there. And this symbol right here, this is a Greek letter epsilon. If we say 1 and then this symbol and then A, what this means is that 1 is an element of A. So that's what this symbol means. It says is an element of. If we draw a slash through it, it becomes is not an element of. Just like with equals, this means is equal to, this one means is not equal to, the slash through it. We can do the slash through the is an element of. A particular set that we like to have a nice symbol for is called the empty set. That's this one right here. The special symbol that we use for it, sometimes we do a null symbol. That's the 0 with a slash through it like that. Sometimes we'll open up curly brackets because if we're starting to define a set, and then we just close them again. So this would be another way to represent the empty set. So there is the empty set. Let's figure out if these statements are false or true or false, whatever. It's kind of hard to see here. Those are supposed to be curly brackets. On all of these, actually. None of them showed up very well. Oh well. Is 3 an element of this set? Well, it doesn't look like 3 is in there, so this would be not true. That's false. 6 is an element of this set. Yep, it's right there. This one's true. 9 is not an element of this set. Well, 9 is not an element of this set, so this is true. This set, these two sets are equal. The only difference between them is the order, the 8, 9, the 9, 8. So that means that they are the same set, because with sets we don't care about the order. This one right here, this one's a little weird. This is the empty set. It's also cut off. It says the empty set is an element of the empty set. So, I said that sets can contain other things, like, for instance, sets can contain sets. So you could talk about a set that contains the empty set or something along those lines. But if I say that the empty set is an element of the empty set, this is not a true statement, because then we would have something in the empty set. One way to think about these sets is kind of folders. They're envelopes. If you have an envelope, this is a nice high-tech drawing here. If we have an envelope that is empty, this is not quite the same thing as having an envelope that has another empty envelope in it. Oops. See if I can draw something here that resembles nested envelopes. There. Let's go like that. There. So it's not the same thing as having an envelope that has an envelope inside of it. So the empty set, and for instance, that's what I'm talking about right here. This is the set that contains the empty set. And there's curly brackets with a 0 like that. The empty set is an element of the set that contains the empty set. This one would be a true statement. This one over here, saying the empty set is an element of the empty set, that one's not true. It's a little tricky to think of, but yeah, if you have questions, we can talk about it in class, or yeah, we can just play around with it.